Welcome to Debug Log, software engineering war stories, architecture decisions, and lessons learned the hard way. Let's dig in.
Okay, you're not going to believe this, but a recent report crossed my desk, and the numbers in it are just, frankly, they're staggering.
Oh, I saw this one. The Majestic Monolith piece, right? I had to reread the executive summary a few times to make sure I wasn't hallucinating.
Exactly. We're talking about a team that went back to a monolith after trying microservices, and they ended up cutting their infrastructure budget by 83%. 83%!
And it's not just budget. It's also a 61% reduction in their code base. They deleted 18,000 lines of infrastructure plumbing and only added 7,000 lines of application logic. That's a net reduction of code to achieve the same functionality.
That's the part that really made my jaw drop. Less code, drastically less cost, and better performance. This flies in the face of so much of what we've been hearing for the last decade.
It really does. It's almost like a punch to the gut for anyone who spent the last 5 years disentangling a hairball of microservices. This whole thing started because this team, like so many others, thought microservices were the natural next step.
Yeah, the article by Yogesh Krishnan Sinaraj, who led this migration, really hits on that. He describes how in 2022, decomposing their initial Django monolith felt like this inevitable logical progression. It was all the buzzwords: independent deployability, domain ownership, technology freedom, horizontal scaling per service.
Right, the checklist from every single tech conference keynote. You're a growing engineering team, you must do microservices. You see it constantly, especially with startups. They hit a certain point, maybe they get a funding round, and suddenly they feel like they need to look like Netflix or Uber.
And Sinaraj admits as much, saying, "Every conference talk we attended validated the direction. Every engineering blog post from companies we admired described the same journey." It's this powerful psychological pull, isn't it? Engineers are drawn to the shiny, complex patterns.
Absolutely. It's the illusion of sophistication. The critical error, as the report points out, was a mismatch of scale. You have a 5-person engineering team adopting the architectural blueprint of companies with thousands of engineers. It's almost textbook cargo culting.
Cargo culting. That's a term David Heinemeier Hansen, DHH, applied back in 2016 when he first talked about the Majestic monolith. He warned against mimicking patterns from organizations orders of magnitude larger, saying, "If I dance like these behemoths, surely I too will grow into one." I'm sorry, but that's just not how the tango goes.
And it's so true. The promise of domain ownership is meaningless when you have more microservices than developers, which this team did. 9 microservices for 5 engineers? That's almost 2 services per person. It's an insane ratio.
Yeah, that's not domain ownership, that's just more things to own. I've seen so many early-stage startups cripple their product velocity by pre-optimizing for a scale they haven't achieved, and honestly might never achieve, all because it's what some FANG company wrote about in a blog post. It's like buying a Formula One car for your daily commute.
Exactly. You get all the maintenance overhead, none of the benefits, and you're still stuck in traffic. And that's really where the distributed systems tax comes in, as Sinaraj calls it.
Right. Once they actually had these microservices, the reality of operating them really hit. Sinaraj reports that his 5-person team was spending more time on the infrastructure that connected the services together than on the product features our customers were paying for. That's the ultimate red flag for any business, isn't it?
It is. That's the moment where you realize you've optimized for the wrong thing. You're building an incredibly sophisticated system for your engineers to manage, not for your customers to use. Debugging distributed traces, configuring API gateways, managing state across multiple services, it all just eats up engineering time that should be spent on value.
And the promise of technology freedom, that you can use the right tool for the job, Sinaraj really challenges that directly. He points out that genuine heterogeneous needs are pretty rare for small teams.
He makes a great point. He says if your ML pipeline genuinely needs Python, and your real-time event processor needs Go, and your customer-facing API needs some specific observability tool, then microservices allow that optimization. But for his team, their pursuit of technology freedom had produced 9 Python services with slightly different fast API configurations.
Oh, I've seen that. Polyglot architecture that just means 5 slightly different versions of Node.js or Java running in slightly different Docker containers. And Sinaraj's killer line? That was fragmentation, not freedom.
That needs to be on a t-shirt. Fragmentation, not freedom. It perfectly encapsulates the reality for so many small teams. You're not gaining unique capabilities. You're just multiplying your maintenance overhead.
And then there's the local development nightmare. This is probably the most relatable pain point in the entire article for anyone who's actually worked on one of these systems.
The report details it beautifully. To spin up their 9-service architecture locally, it required 340 lines of shell script, Docker Compose configuration, and port conflict workarounds. And while the documented onboarding time was about 2 hours, the reality was closer to a full day once you factored in all the inevitable issues.
I can picture it. Is the off service supposed to crash on startup for anyone else Slack message every Monday morning? It's like a running joke that slowly erodes morale and productivity. Just thinking about that makes my blood pressure rise.
Mine too. Contrast that with what they achieved by going back to the monolith. Running Docker Compose up, and the entire stack is up in exactly 3 minutes. That's not just a technical win, that's a massive cultural and productivity win. It frees up engineers to actually build things instead of debugging their dev environment.
So what changed? Why now? The report highlights that this reversal wasn't just about realizing microservices were bad, it was also enabled by new technological advancements, specifically Django 7.0 and Jill-free Python 3.14. Sinaraj basically says Django 7.0 removed the last technical excuses.
Exactly. Historically, Python struggled with high concurrency, I/O-bound tasks in a synchronous environment. That's why you'd see teams spin out a separate microservice in Go or Node.js just for those specific high-throughput endpoints or concurrent database operations. But Django 7.0 introduces full async ORM support.
So no more relying on sync to async thread pool wrappers that add overhead?
Nope. Native async support for all query set operations, async transactions, atomic blocks, and even async model lifecycle hooks. Sinaraj even noted that using the async ORM for critical endpoints reduced our P95 latency by 65%. And crucially, with Python 3.14 removing the GIL, the global interpreter lock, you now get true multi-core parallelism within a single Python process. We're talking up to 2x throughput on mixed workloads. You no longer need a separate microservice to achieve high concurrency. The monolithic framework can handle it natively.
That's a game changer for Python. And what about real-time capabilities? I remember the argument that if you needed WebSockets or server-sent events, you had to spin out a separate service because you didn't want long polling clients tying up your standard web workers.
That was a valid argument, but again, the ecosystem has matured. Django channels can handle WebSockets efficiently within the same architecture. And for modern AI applications, especially with streaming LLM tokens, Sinaraj points out you don't even need WebSockets. You can use server-sent events via Django's streaming HTTP response.
And Django 7.0 improved asyncing support for that, right? So the server can instantly cancel upstream API calls when a client disconnects, making it much more robust.
Precisely. It gives developers real-time streaming without the massive overhead of managing a separate, stateful Redis pub/sub WebSocket server. All those technical excuses for splitting things out just started to crumble.
But what about the big ball of mud argument? The fear that merging everything back means losing code organization, team boundaries dissolving, and everything getting entangled. That's probably the biggest psychological hurdle.
Sinaraj tackles that head-on. He argues that this objection mistakes distribution for modularity. You can absolutely have strict boundaries without network boundaries. His team adopted the modular monolith pattern.
So how does that work in practice?
Each former microservice became a standard Django app within the monolith. These apps expose a public service layer, and, crucially, they are strictly forbidden from importing from each other's internals. All cross-domain communication happens exclusively through those public service layer functions and Django signals.
And how do they enforce that? Because developers, bless their hearts, will always find a way to take a shortcut if they can.
That's the genius part. These architectural boundaries are enforced by static analysis in the CI pipeline, so you literally cannot merge a PR that violates those boundaries. It's code organization and modularity with a built-in bouncer. You get all the benefits of microservice-like organization without paying the network latency and deployment tax.
That's incredibly smart. It means you get the best of both worlds, strict separation of concerns, but within a single application. I imagine convincing stakeholders to go through a 14-month architectural migration, especially one that looks like going backward to some, must have been a massive undertaking. That takes serious engineering discipline and political capital.
It really does. You're basically saying, hey, we spent a year and a half doing something, and now we need another year and a half to undo it. But the numbers, as we talked about, completely vindicate their decision.
Let's hit those numbers again because they are so impactful. 83% reduction in infrastructure budget. That's not just a small saving, that's potentially extending a startup's runway by months, maybe even years.
Absolutely. How many startups burn through their funding because their cloud bill scales faster than their revenue, driven by this unnecessary architectural complexity? It's a silent killer. And then the performance aspect. Microservices inherently introduce network latency. Every time service A talks to service B, it's a network call.
Serialization, deserialization, network routing, retries.
Exactly. But by collapsing it all into a single memory space, those network calls become instantaneous function calls. The result? They got a P99 latency below 1 second back. That's a huge win for user experience.
And the codebase reduction? That's still hard to wrap my head around. The idea that a monolith is smaller than a microservice architecture for the same functionality?
It's counterintuitive, but it makes perfect sense when you think about the glue code. Microservices require API clients, retry logic, Saga orchestrators, complex CI/CD scripts, distributed transaction fallbacks. It's an immense amount of scaffolding that has nothing to do with your business logic.
Wait, so you delete 18,000 lines of that and only add 7,000 lines of actual application logic to the monolith. That means the single monolithic application does everything the 9 microservices did, but with 61% less code. Sinaraj sums it up perfectly. The monolith that's faster to deploy, cheaper to run, simpler to debug, and easier to onboard into is the more sophisticated piece of engineering, not the one with 9 moving parts and a Saga orchestrator.
That is such a powerful statement. It's a redefinition of sophistication. It's not about complexity. It's about efficacy and maintainability.
So this isn't just an isolated incident. It feels like a vindication of DHH's original Majestic monolith philosophy from a decade ago. He was calling it contrarian then, but Sinaraj writes that it feels prescient now.
Totally. DHH argued for an integrated system that collapses as many unnecessary conceptual models as possible, eliminates as much needless abstraction as you can swing a hammer at. He urged small teams to embrace the monolith with pride and a salute. And now, 10 years later, we have hard data showing he was right for a certain scale of team.
But to avoid being dogmatic, when are microservices actually the right answer? Because there must be situations where they make sense.
Absolutely. Sinaraj is very intellectually honest about this. He provides clear heuristics. First, organizational scale. Microservices solve organizational problems, not purely technical ones. For a 5-person team, a monolith is obviously correct. But for a 150-person engineering organization where 12 teams each own a domain, the coordination overhead of a shared code base becomes real, and the autonomy microservices provide is worth the distribution cost. He places the inflection point somewhere around 40 to 60 engineers.
That's a good benchmark. What else?
Second, scale asymmetry. If parts of your application have wildly different scaling profiles, if one component legitimately needs 300 instances and another needs 2, then shared infrastructure is wrong. You split those out. And third, genuine heterogeneity. If you actually need different languages for different tasks, a Rust video transcoder, a Python ML pipeline, and a Go event router, then microservices are necessary.
So, if you don't meet those criteria, you're paying the distributed systems tax without reaping any of the actual benefits.
Precisely. You're just adding overhead for overhead's sake.
This report raises so many interesting questions, like how much of the microservice trend is just resume-driven development? Engineers wanting to put Kubernetes, Kafka, and distributed tracing on their resumes rather than choosing the right tool for the startup's actual needs.
Oh, that's a huge factor. No one gets hired for saying, I built a really stable, simple, monolithic Django app that just works. It doesn't sound sexy on a resume, but it's often the smartest engineering decision.
And the sunk cost fallacy. Sinaraj's team spent 14 months undoing their mistake. How many teams realize they are drowning in microservice complexity but refuse to migrate back because of that sunk cost? Is it harder to build microservices or harder to admit you were wrong and merge them back?
I think admitting you were wrong is always harder. And it's a testament to Sinaraj's leadership and the team's discipline that they actually pulled it off. Most teams would just keep throwing more resources at the distributed problem.
It also makes you wonder about a framework renaissance. With Django 7.0, Laravel, and Ruby on Rails all pushing heavily into async, real-time, and modular monolith patterns, are we entering a golden age for batteries-included monolithic frameworks?
I think we are. The pendulum is definitely swinging back. Developers want to focus on business logic, not distributed plumbing. And as we build more AI-integrated features that require streaming tokens via SSE and background task processing, the simplicity of a single monolithic database and a unified async event loop becomes even more critical for developer velocity.
Ultimately, this report shows that complexity does not equal sophistication. In 2026, the most sophisticated engineering decision a small team can make is to aggressively protect their simplicity.
It's a hard lesson, but an important one. Sinaraj's conclusion says it all. What remains is honest accounting. Does your team size and your scale actually justify the distributed systems tax? Ours didn't. The correction was worth the admission.
It truly was. It makes you think, what's the most complex thing you're running right now that could actually be a lot simpler? And what's stopping you from making that change?
That's a wrap on this debug log. Join us next time for more engineering war stories and hard-won lessons. If any of this hit close to home, subscribe and tell your team.
Ship it carefully.